Cool. So can you remind me of how long we have set aside? Because I don't think we're going to use all of the time. We have 3 hours.
Yeah, it's always fine.
Yeah. Okay, cool. So yeah, this is probably only going to take maybe an hour and a half or something like that. But I will, maybe be faster or shorter, just depending on how quickly we go with all this stuff. So with that being said, I will go ahead and share a link to the workshop in the chat here. And I'll also mention that you can go to github.com/dabbit3, and then you can also just search for this workshop. And I will share my screen here. Actually, portion of my screen might work better. Okay, cool. Yeah, and this workshop is essentially just a README that we're gonna kind of build out. You don't have to clone this repo or anything like that. It's just gonna kind of walk through what we're gonna be doing. The main prerequisite is that you have the ability to use a terminal and you have Node.js installed. Other than that, I listed the prerequisite as Metamask, but we're actually going to install Metamask. You'll see that I've uninstalled it from my own browser, so we're going to kind of kick that off from scratch. I'm just going to install a new wallet. I'm going to expose my seed phrase, and then I'm going to delete it later because I don't really plan on keeping it after this. So with that being said, yeah, welcome to this workshop. This is going to be, it's called, it's kind of like talking about Ethereum, but in reality, the cool thing about what we're about to learn here is that if you learn this tech stack and the stuff that we're about to do, you can actually build across a couple of dozen blockchains at this point, and a lot of them are actually becoming pretty popular. So not only can you build for Ethereum, you can also build for Polygon and Avalanche and Celo and Phantom and a handful of layer 2s and side chains, and probably more stuff coming in the future. So the stack that we're kind of going to be learning is the Ethereum virtual machine. And I look at it as kind of like the React of the blockchain space. You learn once and you write anywhere. And the way I like to look at this technology is that going beyond just the idea of, the fact that maybe people already kind of understand the types of applications that you can build. And you already hear a lot of people talking about, Web3 and all this other stuff, including myself. The way I look at it, though, is more like another, I would say, toolkit that you can kind of add to the existing things that you already know, that just opens the door for more types of applications that you can build. It's not like this type of technology is useful for everything, or it's going to replace everything. Instead, the way I look at it, it's something like when machine learning was introduced and became accessible, we started being able to build additional applications than we were in the past. It didn't replace anything. It just enabled us to do more things. When mobile, the platform came out, it enabled us to build new experiences, but it didn't replace desktop. When virtual reality and augmented reality came out, it didn't replace anything. It just added new things. And that's the way I look at blockchain technology. It's not something that you learn and you focus on and you stop doing everything else. Instead, it's more like, okay, I understand how this stuff works. So now I can spot more opportunities for me to build cool stuff. And I want to continue learning all this other stuff that I've been learning in the past, but I now have this new skill set. And I think that's the best way to approach this technology, as opposed to people that try to maybe say that it's going to kind of replace everything or anything. And in reality, it will probably disrupt certain things, especially financial applications, but it's not going to replace centralized applications. Okay, cool. So with that being said, the way that this workshop is going to go, it's going to be really very straightforward. It's going to be like, you really can't mess this up as long as your environment is set up, because everything should be copy and paste. That being said, I am on a Mac, so there is a possibility that if you're on a Windows machine, that some of these command line commands that we're running might not work, but I've never actually seen that happen before. Like everyone that's taken this workshop has been able to be successful, even people on Windows. So, but that being said, like I've done so many workshops on Windows that I know that often that is kind of the area where I often see things kind of mess up. So I just want to kind of throw that out there. But in general, that idea is that you should be able to kind of like, you know, be able to copy and paste all this code and it should all work. So what we're going to be doing is, this is kind of like, if you learn what we're doing today, it should kind of just open your mind to all the things that you can do. These aren't, well, actually the token contract maybe is kind of a real world thing you might do in the real world, but in reality, it's more just like learning all of the different tools and running the code and like, you know, being able to understand how all this stuff works, as opposed to building something that you would probably use in production. You could probably take the token that we're going to build at the end of this and like launch it or something, but the example hello world first demo that we're doing is more just like, how do you write data to a blockchain and how do you read data from a blockchain, and how does that look? And then after you kind of learn that, I think you can kind of figure out yourself in the future what other types of applications you want to be building. So we're going to be building like 2 different types of smart contracts and then connecting them to a React front end and then calling them. One of them is just a really basic hello world where we kind of write a message to the blockchain and we read it and then we update it. And then the other is actual dealing with tokens and minting our own token and then transferring that token between parties, which is pretty cool the first time you do it and realize like that in the past when you used to write hundreds of lines of code and have to have all this messy configuration to financial applications using all these third-party APIs, having it natively built into the programming language, monetary transactions actually is pretty sweet, and you can do it in just a few lines of code. So with the prerequisites being Node.js installed and Metamask, I don't have Metamask installed anymore because I deleted it a few minutes ago. So I'm going to go ahead and just search for Metamask extension. I'm going to go ahead and install this. And this is going to be our wallet, which is also our identity in the way that we deal with authentication and authorization in the Web3 world. So I clicked that and I added the MetaMask, and now it's going to walk me through all this. And this is kind of the intro. Welcome to in the decentralized web, or connecting to the decentralized web. Pretty cool. I'll go ahead and get started. And if I already had a seed phrase, so it says some browsers do not support MetaMask. What's the alternate if your browser does not? I'm surprised. I've used MetaMask on Brave. I've used MetaMask on the Microsoft Edge. I'm not sure which browsers don't support MetaMask, but oh, Safari. Okay, yeah, I guess that's true. Maybe because it's maybe because it's Apple, they like have something against like some Web3 wallet or something. So let me just Google that. I've never used this wallet tokenary, but maybe you could try that. Instead, I would probably recommend considering to use a different either Brave or Edge or Chrome. You can try this. I think the general thing that we're going to learn is that like once you have an Ethereum wallet in your browser, then you're going to have this global variable that's injected into the window object that's called window.ethereum. So I'm going to go ahead and pin MetaMask to my here. Whoops. And I should be able to just say, you should be able to just like see that window that Ethereum is there. But we're going to actually use that later. But yeah, if you install a browser extension for a Web3 wallet, you should have the window dot whatever that is there. So like for Solana with Phantom, you're going to have window.solana. For Ethereum, it's window.ethereum. For Arweave, it's window.arweave something. So like as you install these different browsers extensions, you'll then have this variable injected into the window that we can access in our code in just a moment. Yeah, I'm a big fan of Brave lately. So that's I either use Brave or Chrome. So if you already have a seed phrase, then you can kind of restore your wallet anywhere in the world. So that this is one cool thing. It's kind of like, you know, if you create a wallet on a browser, that doesn't mean it's like attached to that browser. You're actually given this seed phrase that you can unlock your wallet anywhere, anytime in the world. So therefore, it places a very high importance on the security of this seed phrase. And I think this is one of the areas that probably can be improved in the future around user experience, because we've never had full custody of our own identities in the past. Instead, we kind of hand that responsibility over to like a big company, and we expect them to kind of be good custodians of that. And there's trade-offs. That the good thing about that is that if we lose our password or something like that, we can sometimes get our information like reset and we can get access again. The bad part is that they often leak all of that information, and they also tie our browsing history and our purchase history and all that to our identity, and they put it all together in these databases. And that's kind of one of the areas that Web3 kind of is hoping to improve. But yeah, it just places a very high importance on this seed phrase. So you don't ever want to share this seed phrase with anyone. Anyone that gets this can unlock your wallet and drain all of your money. So you typically might take this seed phrase and write it down. Some people go as far as like, if you have actual money in there, like stored in a safety deposit box or something, you might write half of it down and then like write the other half somewhere else and like not tell anyone where that is. Like there's all types of things that people do to kind of make this something. Like if you have money in there, essentially, like you might worry more about this. But for what we're doing, if you're not storing any money, it's not that big of a deal. So I'm going to go ahead and click create a wallet. And I'm going to go ahead and enter a password. And now I should be able to get a seed phrase. And this is my seed phrase. So I'm just going to copy this to my clipboard. And this is that phrase that you might, you know, try to keep very secure. But for me, I'm not going to keep any money in here. I'm just going to delete it later. So it doesn't really matter. And then now it's just going to ask us to confirm that. So I'm just going to kind of go through and do that. Okay, and if we get that, then we should be done. And now we have this wallet. We should be given at least one, maybe two addresses. Yeah, we're given one address, which is like right here. And we have 0 ETH. And here you can kind of see the assets. You can see activity. You have the ability to like see different other details about your account, whether or not you're connected to this website. You can add additional accounts. So using this seed phrase, you can generate multiple accounts, and each account is just a new private key, public key that you can kind of send money to. But I'm going to be sticking with this account one for now, and then later we're going to actually generate some accounts that we can import later. Okay, so now that we have Metamask installed, then we're kind of good to go. So I'm going to close that and go back to the workshop. So with Metamask and Node.js installed, we can now go ahead and start writing some code. So what we're going to do is like create a React application. We're going to install some dependencies, and then we're going to initialize an Ethereum development environment or an EVM development environment. So to create the React app, I'm just going to run npx create React app. Okay. We'll call this like React app or something like that. And once that's created, I'll just go ahead and change into that new directory. All right. One quick note, in the project, we actually have an entire copy of this app. So like if you get stuck anywhere, you should be able to go there and check out the code. But hopefully you're going to stick to the workshop materials here and get there. But as a fallback, you can do that. All right, so I'm going to go ahead and install all the dependencies, and I'll kind of walk through some of these. And you can do, install using npm or yarn. I'm going to use yarn just because it's so much faster for me. So Ethers is the client side Ethereum like library that we're going to use to talk to the network. So just like if you have a API that you interact with in a web application in the past where we use something like Axios or Fetch, you have to send like an HTTP request to like, send or receive data. And then maybe in GraphQL, you have a GraphQL endpoint and you use something like Apollo or Urkel or whatever, or a Relay. In the Ethereum or blockchain space, you typically are going to be talking to what are known as RPC endpoints. And these RPC endpoints are the interface into the network of the blockchain that you're talking to. So you have these different libraries that allow you to interact very nicely with the network. And they provide like an interface over HTTP that allow you to call methods and stuff like that. So if you're working with Ethereum or the Ethereum virtual machine, the two main ones that you might work with are Ethers.js, which is what we're using, or Web3.js. If you're working with Solana, there's actually, has its own set of libraries. I think it's one of them is Anchor, and then the other is also Web3.js for Solana. But there's, the main ones though for Ethereum will be Ethers and Web3. I like Ethers because it has a slightly nicer API. It's not as well documented, even though like as I would like, but it's better documented than the alternative, which is Web3.js. Web3.js has been around longer though, so there's probably maybe more Stack Overflow answers and stuff on how to do stuff there. But Ethers has better documentation. I think it has a more adoption these days as well for newer projects. Hardhat is a development environment. It's the Ethereum development environment that we're going to be using. And right now there are maybe like two different Ethereum development environments that are the main ones. One of them is Hardhat, and the other one is Truffle. But there's actually a new one that was released yesterday that I'm going to be playing around with. So if you want to kind of experiment with something that's pretty cool, there's this new one that's built in Rust. It's called Foundry. So the Foundry Ethereum Development Toolbox. This is one that I'm going to be playing around with later today. But with that being said, these Ethereum development environments are really nice because they provide you everything that you need to kind of build out blockchain apps. So with Hardhat, you're going to be given, you have a CLI that you can work with. You have the ability to just scaffold out a new project, and that new project will give you smart contracts. It will give you testing. It will give you a script to deploy. It will also give you configuration so you can run a local Ethereum node and then deploy against that. So you don't have to spend even any fake ether or anything like that. You're just kind of working with some local test ether that the environment gives you. So Hardhat is really nice, and it's probably what I recommend right now. Maybe this new one will be better in the future, but it's still fairly new and I haven't tested it out yet. The rest of these are kind of dependencies for testing and stuff like that. So we have like Hardhat Waffle, Ethereum Waffle, Chai, and Hardhat Ethers. But the main two things to remember, like Ethers and Hardhat, these are the two things you'll probably be using quite a bit. All right, so now that we have that installed, all that stuff installed, I'm gonna go ahead and open up the project in my text editor. Yeah, and I guess I'll share the link to this here as well. All right, so now that we have, like once you have Hardhat installed as like a local dependency, you can initialize a new Hardhat development environment using npx. So you don't have to install like a binary or anything like that. So going back to our workshop, you'll see that we have like this npx Hardhat command. So we can go ahead and do that. So I'm gonna run npx Hardhat. And this will go ahead and walk us through a couple of steps. So create a basic sample project, the project root, git ignore, and that should be it. So just by running npx Hardhat, jumping back to your code base, you should see that we have a couple of new files and folders. We have contracts, we have scripts, we have tests with a new file called sample test.js, and then we have hardhat config.js. So the hardhat config, I think, is going to be the first thing that we work with. I'm going to go ahead and just delete all of those comments because the only thing we really need is this module.exports. Going back to our workshop, you can kind of see that the next step is going to be for us to make some updates to this hardhat config. So what we want to do is we can kind of leave the Solidity version as that, but we're going to add these two properties here, the paths and the networks. So right here, I'm just going to go ahead and set these two new keys, the paths as artifacts, so src/artifacts, and then the chain ID, which I'm going to go ahead and walk through now. So you can, if you want to, just copy this whole config, and just like replace whatever we had there with that. It should be the exact same. Okay, cool. So like the two things that we're changing are the paths and the network. So the paths allow us to define different paths that are used by default by the CLI. So one of the things that the Hardhat development environment does is it compiles our smart contracts that are here. It takes that and it compiles it into something that are known as ABIs, or application binary interfaces. And this is what our JavaScript application or our front-end application will use to interact via these RPC endpoints using these libraries like ethers.js. So to kind of make that understandable, like, or a little bit more clear, when we use GraphQL, we have a GraphQL client like Apollo, and we have a GraphQL endpoint, but we can't just call the GraphQL endpoint, using like a post or a put or whatever request. We actually have to send a GraphQL query with that, and that GraphQL query defines the operation that's happening. It's very similar with RPC endpoints and blockchain calls. When we have a function in our smart contract that says something like get this greeting, or like, say hello for a hello world, whatever, we can't just call the endpoint and expect that to work. We need to essentially send along some type of information that describes the operation that we want to happen. So the Hardhat development environment will allow us to compile our smart contract into these ABIs, and the ABIs we can then import, similar to how we might import a GraphQL query and send that along with the requests. We can send these operations that are part of the ABI along with the request. And we don't have to actually write any of that code. It's all kind of written for us by the tooling that we're using. But when we compile these contracts in those ABIs, we need to tell them to go into this SRC directory, because in React, if you try to import anything that you want to use in your app, outside of the SRC directory, it throws an error. So that's kind of like why we're defining the SRC/artifacts. So when we compile, we have those ABIs, and they're nicely available in the SRC directory. The next thing is our chain ID, and this is kind of like dependent on the MetaMask, the way that MetaMask works. So if we go back to our browser and we look at MetaMask, at the very top here, you'll see that we have this Ethereum mainnet. But if you click on that, you'll notice that we have the ability to have other networks. So right here, we have this button that says show or hide test networks. This is actually new. It used to not even be there. It used to automatically show that. If we click that and we say show test networks, and then we go back here, we now see that we have not only Ethereum mainnet, but we also have Ropsten, Coven, Rinkeby, and all these other ones localhost. So the network that we're going to be working with for our local development environment is localhost 8545. So if we go to localhost 8545, it's probably not going to work right this second because we don't have this network set up. But when we switch this network, it automatically has some configuration set up. So it has like the endpoint, which would be localhost, of course, 8545, but it also has a chain ID. And our chain ID needs to match that in our configuration. So we're kind of just saying, okay, by default, MetaMask has this chain ID of 1337. So we want to go ahead and make sure that that matches in our local configuration. So by setting that, we should be able to interact with our wallet on localhost once we have a local network running. All right, so with that being said, we're going to go check out our first smart contract. And we're just going to use the contract that was created for us by the CLI. So if I go now into contracts/greeter.sol, we have our hello world contract. And that's pretty much what it is. It's kind of like the hello world of Solidity. Okay, cool. Yeah. I was just checking to make sure there aren't any questions or anything like that. Yeah, if anyone has any questions, I will probably stop 3 or 4 times to answer any of those. But we haven't done a whole lot so far. So, but if you do have questions either way, just feel free to drop them in the chat. Yeah. So this contract is pretty basic. We have these 2 things right here at the top are kind of necessary. Like we try to compile this contract without setting a license, without just this comment even, I don't think it will actually compile. So you can like leave it as unlicensed or whatever you want to do. You have to define the Solidity version that you want to work with. And then you also have the ability to do like imports. So later on, we're going to be importing a token contract that we can inherit from for creating an ERC20 token or a cryptocurrency. Here, we're importing this Hardhat console utility, which is really nice because it allows us to actually do console.logging just like we're probably used to in JavaScript. But if we didn't have this import and we didn't have the logging, then we would see that we had a smart contract with only like maybe a total of like 15 lines of code. But I'll leave that there just so we can have that. But all the code is happening in this contract. We have a variable that we're setting called greeting, and we're setting it private, meaning that this variable can only be read from within the contract. If we wanted this to be read from outside the contract, we would say public. And it doesn't really matter, in this case, because we're not really like reading it directly from the contract. Instead, we're going to have a function called greet that just returns the greeting, and then this function can read the private greeting and return it here. We have the constructor, which means that when we decide to deploy this contract, this constructor is going to be called, and it's going to expect to have a argument that is a string. And here we're kind of saying the string is going to be greeting, and we're going to then set this private variable as greeting. And therefore, once we deploy this contract, we need to pass in an argument into the deploy function. And in the deploy function, it will be set as our local state variable, and then we can now read that. And then in greet, all it does is just return the greeting. Of A couple things about this function here. It's public, meaning that we can access this from outside of the contract, meaning like you might call this from a front-end application. View means it's not changing any state. It's just returning a view of our state. And then here it kind of defines the value type that we're going to be returning, because Solidity is a typed language. We also now have this last function that is set greeting, and this is going to be creating a transaction on chain, meaning we're going to be creating one transaction when we deploy the contract, but when we update it, we're going to be creating another transaction. And all we're really doing here is just taking in the greeting and then updating the greeting value. So this is pretty basic stuff, but it is a nice intro to kind of how this will work when we start interacting with it from a front-end app. So I think that's about it. This is pretty straightforward contract, I think. And we'll go ahead and just close that. We don't really need to change anything. I just wanted to kind of review that. Yeah, Solidity to me is really easy to get up and running with if you've ever written JavaScript or TypeScript especially. All right, so the next thing we want to do is compile our ABI. And to do that, we can run npx hardhat compile. And then this will look into that smart contracts folder and it will generate our ABIs into the artifacts folder. So we should be able to run npx hardhat compile. And then if the compilation is successful and our configuration is set up properly, then we should have this artifacts folder here. And in the contracts slash greeter.sol/greeter.json, this is, again, we don't have to understand this right now or even ever like touch it or anything like that. But this is our ABI. This is the generated code that we can now use in our API. Again, you could think of this as almost like a GraphQL query or something where we have like a definition of these different functions. So like we have this constructor that we can call, we have this function that we can call, we have this function that we can call. And then it kind of describes like what are the inputs, what are the outputs. So as long as your greeter, your artifacts is there, then you've configured your app successfully, and we should be able to start continuing on here. So what we want to do now is we want to create a local blockchain network. And we're doing this because if we obviously don't want to run tests on the real Ethereum network for a handful of reasons. First of all, it's now become very expensive to develop directly on Ethereum. So therefore, you're seeing people developing on other networks that are Ethereum based, like Polygon, which is a lot cheaper, Arbitrum, Optimism. You even have other Ethereum EVM networks like Avalanche and stuff like that. People are doing a lot of work on, but even then, it's still going to cost you a little bit to deploy or test anything. So instead, you have a couple of other options. You can actually use a real test network. So you have these other real live networks that allow you to get fake Ethereum. So you can say, okay, I want to get some fake Ether for one of these networks, and you can request that from one of these faucets. Someone actually linked to the Paradigm faucet earlier. This is pretty nice because you can just put in your address, and you can authenticate, I guess. You enter your address, you go ahead and claim, and it looks like I've successfully claimed tokens. And then what's going to basically happen is that in the next few minutes, I should have some like tokens on these other networks, and then I can use those. So there, it looks like we already have from Coven, isn't there yet, but we already have like tokens from like one of these networks. So this is kind of like one way that you might test. And the link to this faucet is there. We're not going to be testing on a live network. Instead, we're going to be testing on a local network. But it's pretty simple to kind of interact with a live network. All you need to do is go into the Hardhat documentation and you set up a new network. That might be something like Coven. And then you would set up your configuration here, which would include an RPC endpoint. But Hardhat is going to be localhost, so we don't have to worry about that. But I just figured I'd go off on that because a lot of people are interested. So the two ways to test on a test network would be using like a real live test network, or we can test on local hosts by running our own Ethereum node, which is probably the best way to get started. So I'm going to do that by running npx hardhat node. And this will go ahead and create a bunch of accounts. It'll give us an RPC endpoint at localhost 8545. It will give us 20 different accounts, each of them with 10,000 ETH. And it will give us the private key, which will allow us to import this account into our wallet. And this is nice because we can now have test accounts that have a lot of money in them for us to play around with. Also, one thing to keep in mind is like, this is an array of accounts of like 20 accounts. And when you're testing or deploying locally using the tooling that Hardhat gives you, it automatically defaults to account number 0. So when we deploy and we don't specify an account, it's going to automatically use the private key from account 0. And therefore, you're going to see like, that's where the ETH is going to be taken out of for the gas and stuff like that. So what we're going to do now is like, we have this node running, which is nice. Go ahead and split my screen. And we're going to keep like this Ethereum node running. I'm going to go back to account 0 because I want to import this private key later. But for now, I'm just going to kind of keep it like that. So now that we have the Ethereum node running, we can actually deploy our smart contract. But before we deploy, let's go ahead and look at that script and see what's going on there. So I go to scripts/sample script. And what I'm going to first do is I'm going to rename this script to deploy because it makes a lot more sense since that's what it's doing. So I'll rename the script to deploy. Next, I'm going to delete all of this comments. And what is going to be happening now in this deploy script is that we're going to be calling this main function. And this main function is just going to be calling like, this main function here. And then it's just going to, exit successfully or throw an error or something like that. So when the main function is invoked, we are now going to deploy the contract. And the way that this is going to work is that we set this Hardhat configuration to define that our ABI is an src/artifacts. So with that into consideration, we can automatically assume that we can fetch from that location without having to define the path. So when we say this line right here, we're going to say we want to get the contract factory for greeter. It's going to automatically go into artifacts, contracts, and it's going to find this greeter. And then it's going to kind of say, okay, this is the contract that we want to deploy using this string. So if we had another one for token, we could just say token, and it would automatically, like find the token contract in that artifacts directory. But we're using greeter, so it's going to kind of get a reference to that contract. It's going to then deploy the contract, and we're going to store the return value in a variable called greeter. And we mentioned in the smart contract that we have to actually pass in an argument to the constructor to set that initial state. So the initial state of greeting is going to be whatever we pass in here. So I might say like, hello, ReactEurope. And once that is deployed, we're going to kind of like have this async await where we're just like going to wait for this to finally be deployed. This is going to be extremely fast on a local network, but in a real development environment, it might be a little longer. Yeah, after that's deployed, we're going to go ahead and log out the contract address. We're going to then manually import this contract address into our front-end code. You might want to do something more sophisticated in a real-world app. You might say something like fs.readFileSync or something like that. I don't know the exact API, but then you can just like write this address to a local file, to your local file system, and then you can import it. And then that way you're not having to kind of like manually copy and paste it over. But I think for this example, manually copying and pasting it over is just fine. So now that we know what's going on here, we didn't change any code. We just like deleted the comments and we walked through it. So now we can go and we can copy this script here. And we go back to our command line. And if we paste this here and we kind of like scroll up, we should see some output here. And we're going to be running npx hardhat run scripts /deploy.js, and we're going to be defining the network as localhost. And if you wanted to deploy this to mainnet, or you wanted to deploy this to one of these other test networks, all you would need to do would be pass in that -- network flag to be the name of the network in the configuration that we have set up. So once it's deployed, you'll see that we have this output here that kind of gives us some information around the contract address, the transaction hash, who deployed the contract, the value, the gas used, and the block number. Block number is block number 1 because this is the first time we've ever interacted with this new chain. And we're seeing that we have like just console.log deploying a greeter with greeting hello React Europe. So that all worked successfully. And then we log out the contract address for, the transaction where this contract was deployed here, the address that it was deployed to, I guess you could say. And then what we're going to need to do is like reference this address in the future, because we need to know like where to send the transactions to. And without going too much further into that until we get there, but you can think of this as like when we have a REST API, we need an HTTP endpoint. But when we're talking to an Ethereum node, we need to define like almost like the endpoint, like where does this need to be talking to? And we have the RPC address of the network itself. But we also need to pass in the address that we want to talk to. So this is kind of like, you could think of this as almost like an HTTP endpoint, but this is the address within the Ethereum network that we want to talk to. All right, with that being said, we can keep going. What we want to do now is we want to start interacting with this new network that we have locally from our front-end application, and therefore we need to go ahead and connect to it. So we should be able to go ahead and now be able to connect to localhost. So if I go to my network tab and I choose localhost, then this should work perfectly. And what we want to do now is also import one of those accounts that we created locally so we can have some test Ethereum to work with. So to do that, I can go back here. I'm going to go to my first account, I think, account number 0, and I'm going to copy this private key to my clipboard. So copy the private key to your clipboard, and then we're going to go back to the Ethereum wallet and import that. So using a private key, you can kind of transfer wallets like all over the place. So in addition to your seed phrase, a private key in a real world example, a real world wallet, you never want to expose this or share this or even write this in your local code base or anything. If you ever need to reference a private key or a seed phrase, you always want to have it as a temporary environment variable, not even a permanent environment variable. You would probably be the safest by just like always going that route. You never want to have anything hard coded that's a private key or a seed phrase. So what I'm going to do now is go to import accounts right here. So we have like this button at the top right corner. I'm going to go to import account. I think I have it documented right here. Yeah. Import account, private key. And I'm just going to paste that private key there and click import. And now you see that we have this account number 3 along with our other 2 accounts. And then this one has 9,999.9996 ETH. The reason it doesn't have 10,000 is that when we deployed this contract, it took the 0.0004 ETH out of this this contract. I'm sorry, out of this address, out of this account to pay for that deployment. All right, so with that being said, we look like we have, the ETH and we're ready to continue on. So what we want to do now is we want to interact with this from our front end application. So we've deployed the contract, we've imported our wallet, we have our address, and we're kind of like ready to go on to the next steps. So what I'm going to do is I'm going to open src/app.js. And then this is where we're going to write that code. So I'm going to go ahead and just copy all this code actually, and then I'll walk through some of it. So it looks like we have about 57 lines of code. So if you're in this workshop and you're in like React Europe, you're probably familiar with some of the React stuff. So I probably won't go too deep into that, but we're using use state to deal with local state. These two imports are Ethereum focused. So we're importing the ethers library from ethers.js. We're importing the ABI from greeter.json. So that's where this artifacts directory is. We looked at this earlier. So the greeter.json is just the ABI. We now need to update this contract address with the address from our smart contract that was deployed earlier. So I can go back to my command line. I can just copy this and paste it there. And this is going to be the address that we're talking to. So with this deployment, we should have a default initial state of whatever we set to that constructor. And for me, it was like hello React Europe. So when we call that function in a moment, it should come back as that. In our main app component, we have a initial state of greeting and set greeting. That's set to like null. Maybe we can set it to like an empty string, whatever. We have a fetch greeting and a set greeting function that I'll go over in just a moment. But this request account function is interesting because once you have the Ethereum wallet of choice installed in your browser, you're going to now have this window.ethereum object, which is pretty cool because it will just automatically be there. And then if it's not there, then that means they don't have a wallet. So some logic you might use in that case, you might say like, if like window.ethereum, then do that. But like, we're just assuming that it's there by just having it like this. But this is kind of a really simple way to do logic to see, okay, if is this person in a browser that has Ethereum enabled, or maybe they're in a mobile app that has Ethereum injected, because of course, when we use Chrome on our web browser on our mobile device, it's not going to have that. Yeah, someone said to make sure to set that initial value to empty string. I think it's not going to throw an error or nothing, but it's just definitely best practice. And if you are doing, if you're setting the value manually on an input, you're going to get like an error or warning anyway if you don't do that. So yeah, so like having the window object populated automatically for Solana, Ethereum, all these other networks actually makes it pretty simple. But again, if you're using a mobile app, how would you interact with this website if we were like assuming that? Well, there's most of the mobile wallets that are like good, like Metamask, actually have a web browser as part of the wallet. So you can essentially open Metamask to browse the internet, and then it will automatically prompt you for your connection stuff within the app. There's also a way to do this for people that don't do that. So if someone's just on Chrome, you can actually prompt them to connect to one of the wallets on their device using Wallet Connect. And Wallet Connect will essentially just like have a pop-up, and then you click the browser, you click the wallet you want to authenticate with. It will redirect you and open that app and allow you to sign the transaction, and then kind of redirect you back to the app. So there's a couple of ways to do this on mobile, but it's kind of beyond the scope of this. Fetch greeting. This is going to be the first time we actually talk to the smart contract. Here we're kind of checking to see if we have that window.ethereum available, and all of the logic is happening here. So one of the concepts that you'll see quite often is this idea of a provider or a signer. A provider allows us to have an API to interact with the smart contract using the Ethers library, essentially. So here we can say we want to create a new provider, and we're going to be passing in window.ethereum, which gives us not only the fact that we are using Ethereum, but we're going to be having that RPC endpoint, because we set that RPC endpoint as localhost. So we're able to go ahead and create a connection, and then we're able to bind that connection to our smart contract here by saying new ethers.contract, passing in the address, the ABI, and the provider. So using these two lines of code, this is very important stuff that you'll be using over and over and over, probably if you're building these types of apps, is creating a connection to the RPC endpoint in the form of a provider, and then binding that to the contract by connecting with these three properties: the address, the ABI, and the provider. Or it would be, for a signer, it would be the address, the ABI, and the signer. So once you have that binding, you can now start talking directly to the contract. So you can just call the functions that are there. So in our smart contract, we have this function called greet. We can just say contract.greet, and we're doing that like right here. And then the return value of that should just be that string. And then we also have set greeting. And then set greeting is a little bit different because we're actually writing a transaction to the chain, meaning that this will be some gas use. So therefore, we need the user to sign the transaction. So in order for them to sign the transaction, we create the provider. We then call provider.getSigner, and this will create a signer for the user to be able to kind of approve the transaction from their wallet. And then we make the contract call here, and this will prompt the user to allow this transaction to happen, and we'll tell them like how much this gas cost will be and things like that. And then we say we want to go ahead and get the new, or wait for this to resolve, and then we want to get the new greeting by just calling fetch greeting again, which will just invoke this function. And all this is doing is just logging out the information. And this is just a pretty basic form where we have a function for fetch greeting and a function for set greeting, and then we have an input for updating the form. All right, so with all of that being said, we should be able to go ahead and test this out. So run npm start. Might actually open this in a new window. All right, so pretty basic stuff here as far as the design is concerned. I'm going to go ahead and open up the inspector here. And I want to call fetch greeting. And then here we see hello React Europe. So that actually worked good. And we want to go ahead and set the greeting. So I'm going to say and then this should go ahead and connect us to, I'm not sure why it's so zoomed in. Yeah, it should go ahead and connect us to our wallet. So I want to connect to this account number 3. And then it's going to ask us to sign this transaction and pay whatever gas that it's going to cost. So after that, then we see that we have hello world. And then if we refresh and we call fetch greeting again, we should see the new greeting. So that means we've successfully read and written data to the contract. Does anyone have any questions up until now, by the way? If you do, feel free to go ahead and drop them in. I'll keep an eye on them for the next couple of minutes. Yeah, so fetch greeting is reading from the blockchain, which, by the way, is completely free forever. That's one of the coolest parts, is like all this data, once it's written to the chain, is then available for free forever. And anyone can read it. Anyone can build on top of it. That's one of the greatest parts about this, is that no one has to then pay for hosting, the network itself is keeping all of this data and making it made available. But when you write a transaction to the chain, then you have to pay gas for most of the, well, actually all of the actual blockchains. So that's again why you would only use, I would say, blockchains for certain types of applications, and a lot of the use cases are financial, because if you have to pay, even if it's like a fraction of a penny, it doesn't make sense to just store probably random data like a typical database. Use it for certain types of applications. So the next thing we want to do is look at how to mint tokens. And I was going to take a little bit of break, but I think we can wrap this up in about 30 minutes if we keep going. And then we can all just take the rest of the day and be done with this. And if we take a break now, it might kind of delay. And I think we're, going at a pretty good pace. So what we want to do now is just go ahead and go to the next part of this. And this is like minting tokens. So what we're going to do here is, like, a big part of building blockchain is kind of this idea of having the ability to have digital scarcity and build out financial applications and sending value between parties, and setting up in the future maybe more interesting, like and accessible ways to do e-commerce and things like that. So a big part of that is understanding how tokens and tokenization works. And when you are building out something financial or with tokens, like what we're doing here, you probably wouldn't want to write all this code from scratch like we're doing now, because there are a lot of really great tested, tried, great libraries that are out there that allow you to kind of just import and inherit a lot of code that other people have written that you don't have to write yourself. But I think so we're going to do that, but we're also going to write this from scratch just to kind of show you how fairly basic it is to kind of get all this stuff working. So we're going to write a contract from scratch, and then we're going to replace this with a project called Open Zeppelin that kind of allows you to just import these contracts. A couple of questions came in. The question that I see is like, what does request account do? Yeah, that's a good question, since I just talked mainly about window.ethereum. Window.ethereum, you can call different methods on it. So here we're calling that the dot request, and then you can pass in different methods. The method that we're asking for is request accounts, and this will allow the user to choose which accounts that we want to give the browser access to. This doesn't mean they're getting access to like the private key or any of that stuff. We're just allowing them to connect to those addresses. And then we can then, I would say, use those addresses to do stuff. So one thing that, to make this a little bit more clear, we might say const addresses is equal to that. And then we can say console.log addresses. I guess I can just do this. And then what we want to do is just have a button for a request account. And then we can just kind of log that out. So if I go back here, click request account, you'll see that we have this array of addresses. And if I go here and I disconnect and I refresh, it should prompt me again. And then I can choose multiple addresses if I want. And now I'm giving it an array. I'm, for some reason, only still getting that first address. But there's a way to kind of get, multiple addresses from the user if you want to connect and use different addresses and stuff. Oh, it looks like we're connected. We're just kind of mainly connected to that one. So if I switch to this account, yeah, I'm gonna go ahead and disconnect though, because like we're now connected to all of these. All right, so yeah, let's go ahead and create a new contract in our smart contract directory called token. I'm just going to copy all this code, and I'm going to go here. We're going to create a file called token.sol. And here we're going to go ahead and do that. So we're going to go ahead and create like a contract, and we're going to set a couple of different variables. And you can call this whatever you'd like. This is kind of just like a token name and a token symbol that I'm setting as lazy cats token and LCT. I'm setting the public, I'm sorry, the total supply is public variable to, you know, what is this, 1 million. We're going to create a token where there's like 1 million of the supply. And those are our main variables. And then we're using a mapping for the first time. And a mapping is very similar to like an object or a map, I guess you could say, in other languages. So it would be almost like in JavaScript, we can say const balances is equal to the key being an address and the value being an int. So it would be, you know, therefore we could create a variable like that is a balances object. That would be something like which would be like the address of that. So this way we can kind of have a way to store and get values based on their address, I guess you could say. And I guess the value would be something like, you know, a number, which in our case would be 1,000 or whatever. Like the person that mints this might have 1 million or something like that. So this way we can kind of like get and set balances. In the constructor, we're going to now also be using something new where we have this variable called message.sender. And this is going to be a way, the way that you could kind of think of this is like how in the past, like in an API, we might look to find out who is the caller of this function. And in order to do that, we might read the cookies, or we might read the JWT token, and we might authorize it. And it's like a lot of work. And that's how we do authorization around, you know, who's the caller. Well, in Ethereum, it's actually pretty nice because when we're using this idea of public key encryption, we're signing this transaction and we're sending the transaction along. And then in JavaScript, or in our case in Solidity, we can actually decode that, and we can get that address, and we can know for sure, we can know for certain who the sender of this transaction is very, very securely, and we can then use it. So we don't have to do any logic around any authorization or authentication. We automatically know that the sender of the transaction is going to be available to us as message.sender. So this is kind of the caller. And in our case, it's going to be the person who is deploying this transaction. So what we want to do is we want to give all of the tokens to the person that deployed the contract. So we're kind of making them the treasurer. So we're going to go ahead and transfer all of the 1 million tokens to that user. And then we're going to have a function for transferring and a function for getting the balance of. I don't think that there is a getter for the mapping automatically. I think you would have to create a function to retrieve that information. So for transfer, we have 2 arguments, like where is the transfer going to and how much are you sending? So we want to be able to say, okay, I'm going to deploy this contract, and then now I want to send like 1,000 tokens to my friend. So in this function, we need to pass in who that friend is and then how many we want to send. And then we have this require statement, which again is probably you know, something we didn't touch on yet before. It's also new, but this is a very simple way to do like logic. And this is going to essentially say, okay, if this is not true, then we want to stop execution of this function and we don't want to go to the next line. If it is true, we'll continue going on. But if it's not true, we're going to just like have a message to log out. So here we're basically saying we want to require that the person trying to send this balance actually has that balance in their account. And then the account, of course, is just this balances value. So we are going to say, okay, if that, user does not have that balance, we just want to throw an error and we want to stop execution. If they do, we want to subtract that from this user and send it to that user. So we're kind of just doing all of that transaction in 3 lines of code. Then the balance of allows us just to pass in the address of any contract and get the balance of that user. So in our case, we might just, pass in the first time after we deploy our own address and just see how many tokens that we have. So we'll go ahead and compile that by running npx hardhat compile. So if that compiled successfully, then we should have now in our artifacts a new contract called token, a new ABI called token. So it looks like that worked perfectly. So we should be able to continue on. The next thing we want to do is we want to update our deploy script because we want to now also deploy our token. So in addition to greeter, we want to go ahead and copy. You could, of course, just copy all this code. It should work, but I'm just going to copy the changes and make that a little bit more visible. So if I go to deploy, we have the token and we're, doing that. And then we're waiting for the token to deploy. And then we'll log out the token address. So that's about it. The main difference, I think, is that in the token, the constructor does not take an argument. So we're not passing anything into that deploy script constructor here. We have everything set locally. Of course, you could kind of like change that to set this name or this symbol as part of the constructor if you'd like to. All right, so we can now go back to this and we can now deploy this. So when we deploy this, we should see that we have 2 addresses logged out, one for the greeter and one for the token. So the greeter address is here and the token address is here. So we're going to need that, those addresses in just a moment. So what we're going to do now is update our client code. So I'm just going to go ahead and copy all of this. Quite a bit of code, but it is now going to be, both the greeter functionality that we had as well as this token functionality. The first thing you might want to do is go ahead and update these addresses up here. So we need to now set the addresses for both of our greeter and our token. All right, so I'm going to try to close the functions that we already went through and only focus on the new ones, but there's really not a whole lot that I would say is different than what we learned earlier. We're really doing almost the exact same thing. We're getting a provider for reading, and then we're just calling the contract. I guess one main difference is that this is a read function here where we're calling balance of. Let me open that token back up. And balance of takes an argument. And the argument that we're passing in is going to be the address of the caller, I believe. Yeah. So if I'm calling my own balance, it'll just essentially be bringing that back. And then the other function is send coins. And here we're calling contract.transfer. And we're passing in the account that we'd like to send and the amount. And this will be an instance where we have to like sign the transaction to make sure this works. And then we just have a form for all that. So one thing though that we want to do is that we can now actually import this token into our MetaMask. Just like we have ETH, we can now import our new token. So this is actually pretty cool for the first time using it. So what we want to do to make this work is that all we need is that address for the token. So here we have token deployed to. We can just copy this address, and we can go to assets, and it says like don't see your tokens, import tokens. So we can go ahead and import our token. And I believe it looks like the user interface changed from when I made this screenshot. Like in this screenshot, it shows up really big at the bottom. Instead here, it's just this import tokens button. And I can paste in the contract address. I can set the token decimal to, I think, 0. Yep, so I set the token decimal to 0. It looks like I did put that in the documentation. And then now we should see that we have our 1 million LCT. So with that being said, we can now start sending these tokens. So we have 1 million tokens. We might want to send those to someone else. So to get the balance of my own tokens, I can call get balance. It will ask for the address that I'm going to get the balance of. And here we see that we have 1 million. We now want to send tokens to someone else. So I might go ahead and copy this address for this other person. So we have like these other accounts. I'm just going to send it to another account. And I will put the account there, and the amount is like 100,000 or something like that. Just want to make sure I'm still connected to account 3. Yeah. So now if I click send coins, then it should say that 1,000 or 100,000 coins were successfully sent. And if I call get balance, then my balance is now 900,000 because I've already sent 100,000 to that person. And if I go to my assets here, you'll see that I now have 900,000. And if I copy again this token address and I jump back to account number 2 and I import these tokens, and I should see that I have 100,000. So we've basically created a pretty basic token that we can now send back and forth. But again, you probably wouldn't want to write all of that from scratch because there's a lot of additional functionality that you might need or want to have. So in order to do that, we can use this standard called the Erc20 standard. And this is the standard that every single token that's ever been minted on the Ethereum virtual machine is using. And the standard is like written by, you know, the community, I guess, or by the foundations and stuff. But OpenZeppelin actually has an implementation of that standard that you can then just npm install and use. So OpenZeppelin has all types of contracts that you can use. So this is OpenZeppelin contracts. They have ERC20, they have ERC721. They have like, this is kind of an example of some of the ones that they have and how they're categorized, like finance, governance, tokens, and stuff like that. So the one that we're going to be working with is this ERC20 token. And if we want to use OpenZeppelin contracts, we can just run npm install. And we can say npm install or yarn add at OpenZeppelin/contracts. Someone mentioned the wizard. Which wizard is that? Because I may or may not have used that before. OpenZeppelin wizard. Okay, nice. I have not seen this. This is dope. Looks like it'll just like automatically populate the code for you. This is really cool. So essentially what we're going to do is like have this ERC20 contract, and it's going to look very similar to this actually. So if we go to our code base, instead of having all of that code that we wrote before, after we've installed OpenZeppelin, we can just like make this amount of code, the code that we want to work with. So here we're importing OpenZeppelin, and we're saying that we're essentially inheriting from this ERC20 token. So we're saying our contract is an implementation of ERC20. And then now we're inheriting all these different functions. So which functions are those? If we go to openzeppelin.com/contracts, we look at ERC20. We see that we have all these functions that we're essentially inheriting. So we have our constructor, we have name, symbol, mint, transfer, burn, all these different things. So the only function that we're calling in our code right now is going to be mint, and mint is what allows us to kind of just create or generate the tokens. So instead of hard coding the name and the symbol, we're actually taking these as arguments into the constructor. And another interesting thing is that you see that instead of just minting 1,000,000 tokens and setting the decimal as 0, meaning that if you want to transfer a token, you have to send an entire token. You might instead, like in Ethereum or in other currencies, you can send a fraction of a token, meaning that there are decimal places. There is a fractionalization of that. So by default, the decimal place to 18 decimals. You can change that, of course, but I think it's kind of like a standard that everyone uses. So taking into the consideration that 18 decimals is the default, we need to take that into account. So when we say we want 100,000 tokens, what we really mean is we want 100,000 times with 18 decimal places. So we need to kind of specify that. So that's kind of why you see this 10 to the 18th power here. So we're saying we want 100,000. Whoops. Zoom back in. Yeah, we want 100,000 times 10 to the 18th power. So that's just going to give us, that extra decimal places. So with that being taken into consideration, we might change our deploy script, because instead of not having anything pass into the constructor, we now need to kind of have our own values taken in. So going back to that deploy script, I can call token.deploy, and here we might say we want to pass in the name and the symbol. So for the name, I might say whatever you want to put. And if we go back and run npx hardhat deploy again, then we should have our token deployed now, but with using ERC20 contract, which is pretty simple, like literally 10 lines of code, and we've now made our own token. If we go to our artifacts, the token should reflect that. I mean, yeah, the ABI should reflect the update. See that instead of just having a couple of functions, we have a bunch of different functions that we can call here. We have transfer from. Anyway, we have that full nice API essentially that we can use to interact with our token. So I think the next challenge would be to just update our front end to use that, but I don't think we need to do anything. I think that I think all of the naming and stuff is the exact same. I think that one thing I need to do though is update token contract address. And there we go. Our balance is now like 100,000 to the 8 with 18 decimals. If you try to send a transaction though, I think there might be some error because I think there's something we need to do to reset our MetaMask since we've been jumping around so much, but I can try that by doing something like this. This may throw an error though. No, it looks like it worked. All right, so yeah, you shouldn't have to change anything in your interface because the function names that I used in the old contract were like transfer and they basically mirror the same function names that were used in ERC20. So I think that is it. I think that's kind of the end of this. So I would say if you want to kind of take this a little bit further, some of the things that I would recommend are Ethereum Dev Speedrun. Also, there's a really great repo that's part of Ethereum Dev Speedrun. I need to like update this because I misspelled it. Maybe I need to update these next steps anyway with a couple of more things. There's something called Scaffold ETH. Scaffold ETH is a repo with over 200 full stack Ethereum boilerplates that you can kind of like learn how to do almost anything with. There's a tutorial that I created that is called Building a Full Stack NFT Marketplace that a lot of people seem to like. And there's also a YouTube video for that. Build Space is a great place to learn how to do development, not only for Ethereum, but they also have like Solana and they're adding Avalanche soon as well. And the last thing would be Use Web3, which is a great repo with a bunch of different getting started tutorials, courses, books, and stuff like that. So all those are great places to check out next if you're looking to kind of learn a little bit more. Are those artifacts all safe to deploy? Yeah, they should be. Yep. So yeah, I think that's it. So from here, I will be happy to like take any questions from anyone that's around that has any. And if not, yeah, if there are any questions, feel free to hit me up offline on Twitter, online. Twitter is probably the best place. So Dabbit3 on Twitter. I'll be happy to help you out there. And thanks everyone for checking out the workshop. And I hope that you enjoy React Europe and I hope you learned something. Brain fried. Hope that was a good thing. Yeah, it's a lot. It's a lot. And I tried to make it that nice balance of like simple, but also in depth. So there was a lot covered, but I tried to make it as clear and concise as possible. So awesome. Good feedback. So yeah, thanks everyone for their time today and for checking this out. I hope you enjoy the rest of React Europe. Hopefully next year we'll do React Europe in person.
Cool. Thank you. Thanks everyone.
Bye everyone.
Bye-bye.